Good morning, Year 10. In this video, we're going to go over the area rule for non-right-angled triangles. Now, in the 5 questions for this video, for this lesson, we were looking at, in the 5th question, how to find the area of a triangle given an angle, the base of the triangle, and one of the sides. But the thing is, it only works if we have the side and another side and the angle in between. So, just so you know, for this formula, which the formula is A is equal to a half, AB sine C, we need 2 sides and the angle in between. So, in this case, we've got these 2 sides and the angle in between, but if we were given these 2 sides and the angle in between, it would work. And if we were given these 2 sides and the angle in between, it would also work. In the formula, we have the side A, the side B, and the angle C. As long as we have A, B, and C, it will always work. So in this case, if I had this side, B, C, and the angle A, I've got A, B, C, so that will work. If we had it for this side, A, angle B, and side C, it would also work. Now let's look at 3 examples where this works. So, for the first example, we need to find the area of this triangle to 3 significant figures. So, we've already been given this triangle, but in the pink I've labelled the side A, the side B, and the angle of C. Now, the way that works is we just have to put it straight into the formula. So, I've got my A, which is 5.7, my B, which is 9, and my angle, which is 83, so I do sine 83. And I type it all into the calculator. I like doing it with brackets, because with those brackets, it just shows just a bit more, it makes it less messy, but that's just for me. When you're working with like really, really big equations, those brackets come in handy. Then, when you type it in, you get this in your calculator, but we need 3 significant figures. Now, that's not 3 decimal places, that's 3 significant figures, which is the first 3 non-zero digits, rounded. So we've got 1, 2, 3, and because this was a 4 and this is a 5, we need to make that a 5, just like we would with decimal places. So that's the answer to 3 significant figures. For example 2, we've been given a triangle, but instead of being given the 2 side dimensions and the angle, we need to find a side dimension given the area. So given the area of the triangle is 35 meters squared, find x. So there's x there. So I'm going to put in everything that I have after I label the triangle. So I label A, B, and angle C. And then when I put it in, I've got my half. A is x, B is 10, and my sine 60 because that's my angle. Now that I have that and I've got it all into the equation, the other thing I need to include is my area, which is 35. Now, there's a lot of messy stuff going on here, so I want to clean it up. I'm going to type in everything that I've highlighted here into the calculator. When I do, I get this. I went to 6 decimal places because I want it to be accurate as possible. Then I divide both sides by that number. So I divide 35 by 4.330127, and then I get left with this. Now I didn't say to how many decimal places, so that is my answer, but if you wanted to, you could round to any number of decimal places you'd like. And that's how you find this side of a triangle given the area. What about finding the angle? So for the last example today, we've got the area is 12 meters squared. We need to find theta. So to find theta, first of all, I'm going to label the triangle. Now, you can label it A or B, or in this case, I've done it the other way around. So whenever you do this, the order doesn't matter. All that matters is that you have 2 sides and the angle in between. So, putting it into the formula, we've got a half A, which I did is 8, B, which is 3, and sine theta, where the area is 12. So I pop that all in, and everything that I've highlighted there, I'm going to type in the calculator. When I do, I also get 12. Now I want to get sine theta on its own so I can get theta. So I'm going to divide both sides by 12, And what I'm left with is sine theta is equal to 1. When we do the inverse, which is the shift sign of 1, we get 90 degrees. So that tells me that the angle is 90 degrees. So it's better off to actually draw it like this. But if they drew it like this, we would know what the angle of theta is. So that's why they draw it like this. And they also say most of the time that it's not to scale. So that way you can't just pick up a protractor and just check. Okay. So yeah, that's how you find the area of triangles, or given the area, you can find the side length or the angle. Please copy those down and upload when you are done. Thanks. Have a good day.